So today we will do the next theorem related to the Lebesgue measurable sets. So yesterday we have done the union of two measurable sets is measurable. Then we have a finite sequence of disjoint measurable sets and their union is measurable. And we have proved that the Lebesgue measure of the union is equal to the sum of the Lebesgue measure of all the sets. अब फाइनाइट दो के बाद फाइनाइट पे आए, फाइनाइट जब हम काउंटेबल पे आएंगे, राइट? So this is the next theorem, or you can say one of the property of measurable sets. A countable union, of mutually disjoint measurable sets is measurable. That is, if let En be a sequence of disjoint measurable sets, then the union n running from 1 to infinity En is measurable, and the measure of the union of En is equal to summation of the measure of En, n running from 1 to infinity. So दो part है question के. One, we have to prove that the union is measurable, and the second part is the measure of the union is equal to summation of measure of En. So coming to its proof of this theorem. So as E1, E2, En, they are all, we have uncountable mutually disjoint measurable sets. So हम क्या करेंगे, हम क्योंकि हमने यूनियन पे पहुंचना है, हम सबसे पहले इनका एक यूनियन बना लेंगे. यूनियन आई रनिंग फ्रॉम 1 टू इंफिनिटी EI. आप जस्ट इमेजिन करिए कि आपके पास ये यूनिवर्सल सेट में आपके पास ये बहुत सारे ये काउंटेबल है, अनकाउंटेबल नहीं बोलेंगे, हम इसको काउंटेबल फैमिली बोलेंगे. काउंटेबल फैमिली ऑफ डिसजॉइंट मेजरेबल सेट्स. ठीक है जी. देन ई जो है इन सारे इन सबको इकट्ठा करके ई क्या बन जाता है, इनकी यूनियन. Now the first question is to prove that E is a measurable set. First of all, steps. हम इसको steps में लिखेंगे. Step number 1. For each n belongs to capital N, let. हमने एक सेट बनाया Fn. Fn क्या है, जितने EIs हैं हमारे पास उसमें से जो फाइनाइट कलेक्शन है उसका नाम हमने Fn रख दिया. ठीक है जी. Now each E1, E2, En is measurable. Each E1, E2 and En is measurable, right? It implies the union I running by the previous theorem, union I running from 1 to EI is a measurable set. I have written here measurable sets. It implies, and what is union? It is defined as Fn. So Fn is measurable set, right? Now it implies Fn क्या हो गया, is measurable set. Then अब measurable set की यहाँ पे definition लगाएंगे. Then by definition of measure, इसको आप step number 2 दे दीजिए. Then by definition of measurable set, for any set A contained in R, we have M star A is equal to M star A intersection Fn plus M star A intersection Fn complement, right? Let it be number 1. अब क्वेश्चन क्या है, क्वेश्चन हमने देखो हमने E को मेजरेबल प्रूव करना है. इट मींस मेरा इस प्लेस पे E चाहिए मुझे. Here I want to have E, here I want to have E complement, right? तब हमारा E सेट मेजरेबल होगा. अभी तो सिर्फ हमने Fn को किया, अभी ये हमारा सेट जो है, इट इज अ मेजरेबल सेट. सो हाउ टू प्रोसीड फर्दर. सो अब सारा कुछ, अब थोड़ा इसमें मॉडिफिकेशंस लाएंगे धीरे धीरे. अब एफएन किस में कंटेन्ड है? ऑब्वियसली ई में है. एफएन फाइनाइट कलेक्शन है, ई आपके पास इनफाइनाइट कलेक्शन है. और इसका मतलब एफएन कॉम्प्लीमेंट इज अ सुपरसेट ऑफ ई कॉम्प्लीमेंट. दोनों तरफ ए की इंटरसेक्शन ले लेंगे. इट इंप्लाइज ए इंटरसेक्शन एफएन कॉम्प्लीमेंट, ए इंटरसेक्शन ई कॉम्प्लीमेंट, राइट? It implies M star of A intersection F and complement is greater than or equal to outer measure of A intersection E complement, right? अब हम क्या करेंगे, इसकी जगह पे ये फिट कर देंगे. ठीक है जी. therefore we have M star A is equal to M star A intersection F1. अब यहाँ पे साइन कौन सा आ जाएगा? ग्रेटर देन और इक्वल टू प्लस M star A intersection E complement, राइट? क्लियर? सो ये हमने यहाँ पे इंट्रोड्यूस, क्योंकि देखो यहाँ पे ये एज इट इज है, ये एज इट इज है, यहाँ पे इसका रिलेशन क्या आ रहा है इसके साथ? ग्रेटर देन. सो दैट्स व्हाई वी हैव इंट्रोड्यूस ग्रेटर देन और इक्वल टू, राइट? Now let it be number 2. So what I was telling, मैंने क्या कहा था अभी कि इसको रिप्लेस करना है कॉम्प्लीमेंट से और इसको ई से. एक तो हो गया. इट मींस अब हमने सारा का सारा जो कैलकुलेशन है वो इस एक्सप्रेशन के लिए करना है. सो दैट वी विल हैव एम स्टार ए इंटरसेक्शन एफ एन की जगह एम स्टार ए इंटरसेक्शन ई जो है वो हमारा है. सो नाउ एम स्टार ए इंटरसेक्शन एफ एन, you will put the value. This is next step. Step number 3 or 4, whatever it is. What is the value of Fn? Union I running from 1 to n ei. This is the value. ठीक है जी. So this is summation I running from 1 to n by the property of measurable sets we have already done in the previous theorems. So we have summation I running from 1 to n m star. So 2 implies m star a is greater than or equal to, यानी इस fn की जगह पे हमने ये लगा दिया. This is summation I running from 1 to n m star a intersection ei plus m star a as it is. This will remain as it is, a intersection e complement, right? Now this is the left side and this is the right side. The left side is independent of n. The left side is independent of n, right? It implies making n tends to infinity, we get. ठीक है. आपका अगला स्टेप आएगा यहाँ पे, मैं यहीं पे चेंज कर रही हूँ. सो व्हाट यू विल हैव, इस n की जगह पे क्या आ जाएगा? ये अब यहाँ पे आएगा दिस स्टेप, दिस इम्प्लाइज करके m स्टार इज ग्रेटर देन और इक्वल टू समेशन I रनिंग फ्रॉम 1 टू इंफिनिटी m स्टार इंटरसेक्शन ei प्लस m स्टार इंटरसेक्शन e कॉम्प्लीमेंट. ठीक है जी. बट व्हाट इज m स्टार इंटरसेक्शन e? अब हम इसको सॉल्व करेंगे. दिस वन, ये क्या है? But m star A intersection ei, this is equal to m star A intersection union, sorry, ei नहीं, we will solve m star A intersection e, क्योंकि आपने रिप्लेस करना है किसी तरीके से उसको. सो आप कैलकुलेट करेंगे भी A intersection e क्या वैल्यू दे रहा है. This is m star A intersection union I running from 1 to infinity ei. So you will just put the value here. ठीक है जी. And this comes out to be m star union I running from 1 to infinity A intersection ei. ठीक है जी. And we know that outer measure is countably subadditive. So there, here you will have less than or equal to union converted into summation. This is m star A intersection ei. The reason you will give m star is countably subadditive, right? So it implies summation I running from 1 to infinity m star a intersection ei, right? This is greater than or equal to m star a intersection e. तो ये वाला जो पार्ट था वो इसके साथ हम कंपेयर करेंगे. सो लास्ट में आपका जो स्टेप आया था वो ये था जिसको आपने नंबर 3 देना था. That is, इससे पहले, that is, we have m star a is greater than or equal to summation I running from 1 to infinity m star a intersection ei plus m star a intersection e complement. This was number 3. Number 3, right? Now we will substitute the value of m star a intersection ei. ये पूरी वैल्यू जो है इसकी जगह कौन रिप्लेस हो जाएगा? m star a intersection i. So I'm writing over there. So it implies from, this is number 4, from 3 and 4 we get m star a is greater than or equal to, so we will replace this by m star a intersection e plus m star a intersection e complement. So this is the necessary condition for a set to be a measurable set. It implies the set E is. So I am writing here, it implies the set E is measurable. It implies union I running from 1 to infinity. EI is a measurable set. Right? So the first part of the question is done. Now we will do the second second part of the theorem. Second part of the theorem, what we want to prove, measure of union n running from 1 to infinity en is equal to summation n running from 1 to infinity measure of en. ये prove करना है हमें, right? Since union I running from 1 to infinity ei is measurable. It means the outer measure, the measure of union I running from 1 to infinity. The Lebesgue outer measure is equal to Lebesgue outer measure. This one. ठीक है जी? Let it be number 5. Since each ei is measurable, it implies measure of ei is equal to m star ei, right? Now, by countably subadditive property. Now, by countable subadditivity of outer measure, we have m star union I running from 1 to, ये outer measure की property लग रही है. This is less than or equal to summation I running from 1 to infinity m star of ei, right? And what is the value? By number 5, this is equal to m of union I running from 1 to infinity ei, right? And this is less than or equal to number 6 क्या था जो अभी लिखा आपने, measure of ei is equal to m star of ei. This was the number 6. So you will replace the outer measure by the Lebesgue measure, right? So less than or equal to, one of the property is done. अब हमें इसका greater than or equal to वाला part prove करना है. So let it be number 7. Now, measure of union I running from 1 to n ei. It is less than or equal to, this is some property same, summation I running from 1 to n measure of ei. This is by the previous theorem, right? And let it be number 8. Now, union I running from 1 to infinity ei, definitely it is a superset of union I running from 1 to n ei. It implies m star of union I running from 1 to infinity ei. It is greater than or equal to m star union I running from 1 to n ei, right? And the outer measure is equal to the Lebesgue measure, union I running from 1 to infinity ei is greater than or equal to measure of union I running from 1 to n ei, right? And again, this is by this property. This is equal to, this is greater than or equal to, this is greater than or equal to summation I running from 1 to n measure of ei. This is by number 8. This is by number 8. So it implies what you have, measure of union I running from 1 to infinity ei. This is greater than or equal to summation I running from 1 to n measure of ei. So the left hand side, this is independent of n. So let's make n tending to infinity in this part. यहाँ पे हमने n tends to infinity कर देंगे. So this will become summation I running from 1 to infinity measure of ei. So this will be number 9. What was number 7? The number of 7 was measure of union I running from 1 to infinity ei. It is less than or equal to summation I running from 1 to infinity measure of ei. This was 7. This was 9. So from 7 and 9, what you will get? Measure union I running from 1 to infinity ei. That will be equal to summation I running from 1 to infinity measure of ei. That we want to. So this is the theorem related to the countable or infinite countable union of mutually disjoint measurable sets. So it's again a measurable set. Now I'm coming to the next theorem. Next theorem is, it's not about the disjoint sets. It's only about the measurable set. The union of countable union of measurable set is measurable. In the previous theorem, one condition that we have given, all the measurable sets are mutually disjoint. But in this question, the statement is a countable union of measurable set is measurable. Right? Or we can say that if En is a sequence of measurable sets, I have written measurable sets, then union and running from 1 to infinity, En is also measurable. Right? So let's come to its proof. Construct a sequence. So you have to remember, वो E से शुरू हुआ था. E was union I running from 1 to infinity ei. So it will start from. Construct a sequence Fn. What is Fn? Fn is F1 is equal to E1. F2 is equal to E2 minus E1. What is F3? F3 is equal to E3 minus E1 union E2. So now to generalize करेंगे. What is Fn? Fn is equal to En minus union I running from 1 to n minus 1, and here is ei dashed. So first of all, we will construct a sequence. We have construct a sequence. तो इस तरह से ये कंस्ट्रक्शन हुई है कि ये जो सारे सेट्स हैं E1, all the sets that will be moreover all EIs are measurable, and we will prove that all Fn's are disjoint measurable sets. So this is the step number 1. Now we have step number 2. In step number 2, what we will do? We shall prove that step number 2 के ऊपर लिखेंगे. We shall prove that Fn is a sequence of disjoint measurable sets. ठीक है जी? Since E1, E2, so on up to En minus 1 are measurable sets and union of finite number of measurable sets is measurable. Right? It implies union I running from 1 to n minus 1, EI is measurable. Simple. जो दिया हुआ है उसके हिसाब से. Also, every set En is also measurable. Right? इसका मतलब if A and B are two measurable sets, if E1 and E2 are two measurable sets, then E1 minus E2 is also a measurable set. It implies En minus union I running from 1 to n minus 1 EI is measurable. The reason is the difference between two measurable sets is measurable. And how it is defined? It is defined as Fn. So Fn is a measurable set, right, for all n. So first thing that we have proved that Fn is a sequence of measurable sets. So it's from there, जिस तरह से हमने सेट को बनाया, from the formation of set, F1 क्या है? E1, F2 क्या है? E2 minus E1. तो F2 के जो एलिमेंट्स हैं उसमें कोई भी एलिमेंट E1 का नहीं है, ठीक है? F3 में कोई भी एलिमेंट E1 यूनियन E2 का नहीं है. It means and what is Fn? Fn is equal to En minus union I running from 1 to n minus 1 EI. By the formation of the sets Fi, we have, right? You can write like that, right? It implies Fn is a sequence of disjoint sets. Moreover, we have already proved that each Fn is a measurable. Therefore, Fn is a sequence of disjoint measurable sets. And the previous theorem states, if you have a countable union of disjoint measurable sets, then their union is also measurable. So we will use that theorem here. क्योंकि इस क्वेश्चन में हमें EI's डिस्जॉइंट नहीं दिए हैं, हमने एक ऐसा सेट बना लिया, उस सेट के जो सारे मेंबर्स हैं वो म्यूचुअली डिस्जॉइंट हैं और वो मेजरेबल हैं. Then by applying the previous theorem, it implies union and running from 1 to infinity, Fn is a measurable set. This is by applying the previous theorem, right? Now, step number 2. We claim that union and running from 1 to infinity En, this is equal to union and running from 1 to infinity Fn. दोनों क्या है? सेम. यानी एक बार ये पूरा सेट इसके अंदर कंटेन होगा. This is contained in this and this is contained in this. Since each Fn is contained in En, definitely for all n, it implies union of Fn is contained in union of En, and running from 1 to infinity and running from 1 to infinity for all n, right? So one point is clear. Now to prove, इसको आप step number, इसमें आप one part हो गया, step नहीं करती. Now to prove union of n running from 1 to infinity En is contained in union and running from 1 to infinity, ये प्रूव करना है. एक सेट दूसरे में कब आएगा? जब यहां से एक पॉइंट लेंगे तो वो किस में जाना चाहिए? बी में. अब यहां से एक पॉइंट उठेगा, आप दैट इज करके लिख लीजिए. That is for all x belongs to union and running from 1 to infinity, En implies x belongs to union and running from 1 to infinity. यहाँ तक पहुंचना है, ठीक है जी. So let x belongs to union. Union में आ रहा है पॉइंट, इसका मतलब किसी एक में आएगा. For at least for some k, ठीक है जी, belongs to n. Let small m be the smallest positive integer such that x किस में आ रहा है, em में आ रहा है, राइट। दैट इज x अगर em में आ गया तो x किसी और ei में नहीं आएगा, फॉर ऑल i इज इक्वल टू 1 to 3 so not to m minus 1, ठीक है। किसी एक में आना है तो हमने किसी em में ले लिया, मतलब बाकियों में नहीं आया। इसका मतलब x सिर्फ em में है, कौन बाकी जो है वो निकाल दिए, i रनिंग फ्रॉम 1 to n minus 1, ऐसे लिख दिया, ठीक है जी। और ये इस एक्सप्रेशन का नाम क्या है, fm, राइट। अगर x fm में आ गया मतलब x यूनियन में आ गया, एक से यूनियन में तो पहुंच सकता है, यूनियन से सब में नहीं जा सकता, यूनियन में एटलीस्ट किसी एक में जरूर होना चाहिए, ठीक है जी। सो इट इंप्लाइज x कहां से शुरू किया था, यूनियन n रनिंग फ्रॉम 1 to infinity en से, पहुंच कहां गया, x belongs to union n running from 1 to infinity fn में पहुंच गया। It implies union n running from 1 to infinity en is contained in union n running from 1 to infinity fn. So previous वाला 1 था, this is 2 है, therefore 1 and 2 we get union n running from 1 to infinity en is equal to union n running from 1 to infinity fn, right? और हम प्रूव कर चुके हैं ये क्या है, we have already proved that this is a measurable set and this union is equal to this union, it implies this is also measurable. This is also a measurable set. I hope the point